My name is Krish Kadakia, and this is the video submission portion of the statistics final, and here is my UCID. Okay, going on to question 1. The 5-step hypothesis testing process. For the first step, we identified the null and alternative hypothesis that need to be tested. So for the null hypothesis, I got H sub 0 to equal 210. And 210 is the average total cholesterol level given in the question. And then for my alternative hypothesis, I got H sub 1 to be greater than 210. And this corresponds to a right-tailed test, for which a z-test with one mean with known population standard deviation will be used. The second step is the rejection region. Based on the information provided, the significance level is alpha equals 0.05, and the critical value for a right-tailed test is z sub c equals 1.64. And the rejection region for this right-tailed test is z is greater than 1.64. The third step is the z statistic, which is computed in the equation, which is z equals the sample mean subtracted by the average total cholesterol level we're given, which is 210, divided by our standard deviation, divided by the square root of our square root of n. And you get z, which then goes to z equals 214.71 minus 210 all over 29.66 divided by the square root of 133, which gives us 1.831. So the z statistic is 1.831. And the standard deviation 29.66 was calculated by taking the population variance and square rooting the population variance, which was 879.47. So the square root of 879.47 is 29.66. The fourth step is the decision in the null hypothesis. Since it is observed that the z statistic is 1.831, which is greater than the rejection region 1.64, it is concluded that the null hypothesis is rejected. Using the p-value approach, the p-value is 0.0335. And since p of 0.335 is less than 0.05, it is also concluded that the null hypothesis is rejected. The fifth and final step of the five-test hypothesis process is the conclusion. It is concluded that there is enough evidence. It is concluded that the null hypothesis H sub 0 is rejected. Therefore, there is enough evidence to claim that the population mean U is greater than 210 at the 0.05 significance level, or the 95% confidence level. Question 2. For question 2, part 1, to figure out the point estimate, you have to take the difference between the two sample means given. So it would be x1 minus x2, which is equal to 214.71 minus 193.2, which equals 21.51. So the point estimate for part 1 of question 2 is 21.51. Part 2, the standard of error is calculated by standard deviation of 1 squared over n1 plus the standard deviation of 2 squared over n2 to the power of 1/2. So square root that. So standard deviation of 1 is 29.66 squared all over 133 plus 33.04 squared over 41 to the power of 1/2. And then the standard of error for part 2 is equal to 5.765. For part 3, the central limit theorem can be applied because as the sample sizes are large and both samples n1 and n2 are greater than 30, we can use the central limit theorem. And to find a 90% confidence interval for the population mean of the primary hypertension patient's total cholesterol, we have to do we first have to determine the z value for the 90% confidence interval, which is 1.645. Once you have determined that, to figure out the confidence interval, you'd have to do the difference. So you'd use your point estimate plus or minus your z value, which was z value of the 90% confidence interval, which is 1.645, and multiply that by your standard of error. So you would get 20. So you would get x1 minus x2 plus or minus z sub 0.05 multiplied by our standard of error, which then goes into 21.51 plus or minus 1.645 multiplied by 5.765, which then gives us 21.51 plus or minus 9.483. So our confidence interval for part 4 of question 2 is 12.027 all the way to 30. No, the confidence interval is 12.027 and 30.993. Question 3. Question 3. Part 1. To describe the type of relationship between political affiliation and opinion on tax reform, we have to do a chi-square test to check, and then the null and alternating hypothesis. For the null hypothesis, it would result in that there is an independence between political affiliation and opinion on tax reform, and for the alternative hypothesis, it would be that there is the dependency between political affiliation and opinion on tax reform. Those would be the two relationships that we would have to test. For part 2, to check the independency of the two variables, we have to set it up for a test statistic. And the equation for test statistic is x squared, which is the test statistic, is equal to sigma of O minus E squared all over E. And O stands for observed frequency, and E stands for expected frequency. Once you have it solved out, which we did in this table right here, where O is the Democrat, as shown in the table, it's shown as 138, 83, 64, 64, 67, and 84. It's the six numbers that make up the table. And then expected, you have to solve when you add 138 plus 64, which results in 202. And you'd have to divide 138, divide by 202, and get your answer. And you would do that for all 6 numbers, which is your expected. And then you'd subtract your observed minus your expected. So this column minus this column, and it would result in this column right here, this third column, your observed minus expected. And then to calculate for test statistics, you'd have to square it, which would give you this column, and then you divide it by your expected again, which would give you your test statistic. But since you have to sigma it, which means add them all together, your total or your complete test statistic is right here, which is 22.15, which is right there, 22.15. So you figured out your test statistic to be 22.15, and you have to calculate your degrees of freedom, which are the number of rows minus 1 multiplied by the number of columns minus 1. And there are 2 rows, so you subtract 1 and get 1. And there are 3 columns, you subtract 1, so you get 2. So your degrees of freedom would be 1, because there's 1 row, and 2, because there's 2 columns. So it would be 1 times 2 is equal to 2. And your level of significance is 0.01. Your critical value using the chi-square table is 9.210, and since the test statistic is greater than the critical value, we reject the null hypothesis. So we conclude that there is a dependency. There is the dependency between political affiliation and opinion on tax reform. Question 4. To calculate the Pearson sample correlation coefficient, we have to use the equation R equals n sigma x sub I y sub I minus sigma x sub I multiplied by sigma y sub I all over the square root of n sigma x sub I squared minus sigma x sub I squared multiplied by the square root of n sigma y sub I squared minus sigma y sub I squared, which the equation is right there. Right there. That one right there. Once you solve for all your numbers, and so in the numerator you get 1,932.897 subtracted by the square root of 10.6117 multiplied by the square root of 455,352.6, which results in your Pearson sample coefficient correlation being R equals 0.8793. And since it is so close to 1, it indicates a strong positive linear relationship between birth weight and age at weight, because both variables, x and y, are moving together. So as y increases, x increases as well. 2. So we have to test the hypothesis at p sub xy equals 0 for the right tail alternative at a 5% significance level. So first we have to determine our null and alternative hypothesis. So for the null hypothesis, h sub 0, p is equal to 0. And then for our alternative hypothesis, h sub 1, p is greater than 0. Since we're given our level of significance, which is 0.05, and since we determined r in the first step, which is 0.8793, and then n is equal to 15, our test statistic formula is the square root of n minus 2 multiplied by r all over the square root of 1 minus r squared, which can be seen right there. That's the formula for test statistic t. Since we in our table they're shown to be 15 values, n is equal to 15. So you take n minus 2, which is 13. So you square root 13 and multiply it by r, which we as we determined in step 1 is 0.8793. And you divide that by 1 minus r squared, which is 1 minus 0.8793 squared. And it results in 6.6566. Critical value of t at 13 with a 5% level of significance is 2.1603. So t sub c is equal to 2.1603. And because our test statistic is greater than the critical value of 2.1603, so 6.6566 is greater than 2.1603, we can conclude that the null hypothesis is rejected and the population correlation is positive. For part 3, we want to determine the line of best fit of y on x, which is y hat is equal to a hat plus b hat x, where b hat can be solved at 18 weeks. B hat can be solved. The b hat formula is equal to r times standard variation of y divided by standard variation of x. R is equal to 0.8793 as determined in part 1, and the standard variation of y, which is also determined in step 1 to solve for R, is 674.7982, and the standard variation of x, also determined in step 1 to determine R, is 3.2575. So B hat is equal to 182.1472. It is shown right there. B hat is equal to R times standard variation of y over standard variation of x, which is equal to R 0.8793 multiplied by standard variation of y over standard variation of x to get 182.1472. And since we have B hat, we can solve for A hat by isolating A hat. So we get A hat is equal to y minus B hat x, which is equal to 2976.6, which is determined from the table when solving for 18 weeks. Subtracted by 182.1472, which you just determined in the step prior, multiplied that by 38.36, which is the x value in the table provided. And all of that subtracted and multiplied together results in negative 4010.57. So our A hat is negative 4010.57, and our B hat is 182.1472. So our formula looks like y hat is equal to negative 4010.57 plus 182.1472x. And if we're trying to solve for the line of best fit at 18 weeks, all we would have to do is plug in 18 in for x. So we would get negative 4010.57 plus 182.1472 times 18. And that would result in y hat equaling negative 731.917. It can be seen right there. So we determined our original line of best fit formula. Then all we'd have to do is plug in 18 for x, which would result in negative 731.917. And that is the end of my submission. That is the end of my video for the statistics video submission. And here is my UCID card, just again, to verify. Thank you.